Welcome, everybody. You know, Stable Diffusion, the open source AI generator, has a RESTful web service. That means I can call it from Java if I want to. I can add image generation from Stable Diffusion to my Java program. That's what I want to show you today on Tales from the Jar Side. So the idea is if I'm ever going to access a RESTful web service from Java, all I need is a way to do GET and POST requests. I need to transmit data to the RESTful web service and get it back. And I need a parser and generator, something that can generate JavaScript object notation and then parse the results coming back. Fortunately, Java 11 has a built-in HttpClient API to do the networking. And I can always add a parser like Google's JSON to do the parsing and generation. So let's see how all this is done. Now right here, I'm on the home page for stability.ai. In fact, I'm at platform.stability.ai. This is the developer site for Stable Diffusion. If I go to the documentation here, then the Getting Started page starts you with doing authentication. You do have to register and get a key, but they kind of set it up as soon as you create an account. Now, when you create an account, they'll give you 25 credits and then the option to purchase as many more as you want. Credits cost roughly a penny a credit, and it costs about 2 or 3 credits to make an image. What this generally means is it's about a cent and a half to 2 cents to make an image, which, hey, that I can handle. At any rate, there's authentication, but I'm going to skip all that. You can go into the credits and billing section and find out your balance and go ahead and set up a credit card or purchase some credits. No, I'm going to go directly to the REST API. See, they already have a Python client and a TypeScript client. I'm not interested in that. I want to incorporate this into existing Java code. So I'm going to go to the REST API. Now, let me scroll down a bit, and the first thing that we see here is how to find out the balance on your API. And this is interesting because this one is a GET request. You submit a GET request to this URL, and you don't have to send any data at all other than, as you'll see in the curl request, your API key. And from that API key, it will tell you exactly what your balance is. You can kind of see in the curl request here that you set the authorization with a bearer flag and the stability API key. And then they have, well, it's not exactly an error because it doesn't hurt anything, but it's not what they meant, I'm sure. There's no need to set a content type header when you're not transmitting anything. I think they meant to set an accept header because they're getting JSON data back. But it doesn't really matter either way because you're only going to get a JSON data back. Now here's the JSON response. This couldn't be any simpler. All you're getting is credits, which is basically a double. If you look in the response here, they point out that it's a number or a double, the balance of the account or organization associated with that API key, and it's wrapped in a JavaScript object notation object. That's it. So that one's going to be really, really easy. All I need to do is to make a Java record to represent this and be able to send a GET request, and I'm good. Now, before I do that, let's take a look at the other endpoint that comes up when you do GET requests. This is to find out what the various engines are that Stability AI supports. The thing is here, there's really only one engine I'm interested in, but what the heck, it's easy enough to do. Let's get a list. So if I look at the curl request again, then once again, you set an accept header to JSON data. See, now this one they got right. They said accept header instead of content type. And you put your authorization here, and there's the endpoint you access. And the response this time is a little odd, and this happens in some of these RESTful web services. Normally, your output is not an array. You know, it's a JavaScript object notation object that has an array in it. So I have to do a little bit of manipulation to handle that. But if you think of this as an array of, say, engine objects, seems like a reasonable approach, then each engine object in the array has a description, an ID, that's the unique identifier for that engine, a name, and then there's a type here which is audio, classification, picture, storage, text, or video. And you can see that the sample list here they're showing, they're all picture, every single one of those engines. And the one that we're actually going to wind up using is this one, Stable Diffusion XL 1024 version 1.0. This is by far the best. In fact, I don't really have any reason to use any other one. Rather than this, all the others are older or not as capable. So this is the one I'm going to want, but we may as well take a look at the list of engines. Now the next step is the generation of images. So that takes a different URL. You actually put in version 1 generation and then an engine ID inside there, and then /text to image. And the engine ID comes from that other request with the engines in it. And this one's going to take a little bit more doing, although still not too bad. In the JavaScript object here, you see that there's things like config scale and clip guidance preset or whatever. A lot of things I don't really know much about or care much about, but they discuss inside the documentation. What I will point out are a couple of items. One is that notice they're using, quote, snake case, lowercase with underscores, for all of the different entries inside here. Now, some of them aren't multiple words, like height and width and samples. That's the number of images you want back. That's fine. Also, the text prompt goes inside another object that has text, like a lighthouse on a cliff, and then a weight, which governs how closely the results are supposed to be influenced by the text here. And you actually put in an array of text prompts. You could have a collection of them, if you will. So this is the input, and then the response you're going to get back is, again, another array, but inside that array, they have an additional array, and then we get the part we want. The individual JSON objects here have a base 64 element. That's the base 64 encoded string representing the image data, a finish reason, and a seed. And that finish reason, they point out down in the bottom here, is in fact a success if it worked, an error if it didn't work, and then this option called content filtered, indicating the result was affected by a content filter, it may be blurred. I'll check just to make sure that I'm not getting an error, and then everything else should be fine. Okay, with that as a quick overview of the API, let's go to the code. Now, all of this code is in a GitHub repository, and I will put the link in the description and probably in a pinned comment just so you can get at it pretty easily. There's the base URL that I need to go to, and as we're going to see when I get the engines, this is the Stable Diffusion XL, SDXL as they say. That's the engine I want to use. Now, I took my key and I made it an environment variable, and therefore I can just read it from Java that way. Now, I do need a JSON parser and generator, and for that, I'm using Google's JSON. This is a very simple parser. It has a very nice property here where you can say set field naming policy to lowercase with underscores. And the benefit of doing that is that it will automatically convert the snake case in those JSON objects into camel case in my Java classes. That's going to be great, except for one element, and I'll show you what that problem is a little bit later. Okay, now here is my HTTP client. This is the HttpClient API that was added back in Java 11, and everything's made through builders. You use a builder to create the client. You could set connect timeouts. You could follow redirects. You could put in a proxy if you need to. You could do basic authentication. And then you make a request also through a builder, which also could be get, post, put, or delete. And then you either do a send or a send async, depending on you want to block and wait for the response or wait for a completable future, either way. So what I'm going to do is get ready with my authentication header. And the first thing I want to do is get that balance. Now remember, the balance was almost trivial. It was a JSON object that wrapped a double. So what I did here is I made a record. Records became GA in Java 17. They were out in 16 and they're ready in 17. So I just have a record called balance that takes a double and I'm done. That's all finished. So in this case, all I need to do to get the balance is to make a GET request to that URL, that endpoint, and get back a balance. Now, the method I put together for making GET requests takes the endpoint and the class to convert into. So here's my builder for the request, setting up the URL. There's the authorization header with the key in it. There's my accept header for JSON. I said GET, but the honest truth is that's the default, so I don't even have to do that. But what the heck, it's documentation. And then built the request. So in the try block, I sent this. I didn't mind going and doing a blocking call on these. It doesn't take too long. And I send the request and I take the body and just treat it like a string. So that's my HTTP response. I could check that the status of that is 200, but I didn't do that yet. Instead, I use Google's JSON again to extract the body and convert it into my balance object. Let's see that in action. I mean, that's all I had to do. In my test class here, after instantiating the class that has all that logic in it, here's my quote test. It's not really much of a test. I'm just going to get the balance and print it. And let's take a look at that one. That was very, very quick. And one of the nice things about records is they have a built-in toString method. So the toString method here is showing I currently have 971.2 credits available out of my 1,000 I had for my $10. So yeah, I've been doing some experiments, but at a couple cents an image is not a big deal. And I don't think the balance query, in fact, I know the balance query didn't cost me anything. That's fine. Okay, so the balance is the really easy one. Now let's go and see the engines. Now to get the engines, I have to go and map that structure. The overall structure was started with an array and everything. So what I did is I made a record called engines plural, got an S on it, and it contains a list of engine. That's all that's in there. So this is basically my array of engine objects, just a list inside an object of some kind. And when I go into engine itself, an engine has an ID. That's the ID I'm going to need to specify when I call generate. A name, a description, and I took the various types and made them into a record. So, not a record, an enum. So that type is this Java enum, audio, classification, picture, storage, text, and video. The only one that I get back is going to be picture. But let's see it. So again, this is a GET request to that slightly different endpoint, getting back the engines object. So in this case, I'm going to call get engines and get them back. And for each one in the collection, I'll print them out. And let's take a look at that. And you can see here, there's each engine object. There are the IDs. And there's the one I want, by the way, Stable Diffusion XL 1024 version 1. They all have individual names. The descriptions don't really tell us much that the name doesn't. And they're all of type picture. So fine, now I know what my engines are. Now I'll go back and let's take a look at generating an image. I hard-coded in my SDXL engine as a constant so that I don't have to keep typing that over and over again. This time to generate images, I need a prompt and I need to know how many images to make. Now, they didn't call it an actual name, but the name I've chosen for the body that I'm submitting is called payload, and I think that's consistent with their Python API or their TypeScript API. Now, a payload contains, now I took all this documentation from their website, from the API reference, and there's the valid dimensions and sampler and config scale, all this stuff. And you can see that I am using camel case inside my Java, even though I know that the API, the JavaScript object notation stuff, uses snake case. Now, the only things I'm really going to care about here are the height and width. The samples is the number of images, and then my list of text prompts. And text prompt is a simple combination of the text and the weight. And that's it. That's all I need. So back to the API, I've hard-coded it to use the defaults pretty much. The style preset is where you get to choose one of a number of different possibilities for the type of image you want. I put in photographic just because that's what I want to try out, but that's easy enough to change. And then I put in a list of text prompts, but I only have one prompt, and that prompt is coming through the generate images method. Also, I'm going to submit the number of images, and that's another argument. There's my payload. This time I'm going to make a post request to that engine, the URL with the engine in it. I'll convert that payload to JSON data to go in the body, and this time I'm going to get back something of type artifacts. Again, a plural thing to deal with those arrays. So an artifacts is, again, a record that contains a list of image objects. And an image object has the actual data in it. That you get back this base 64 encoded string. So it's giant. You don't want to just log this. It's huge, or save it into files or whatever. And then there's a finish reason and a seed. And you'll notice one odd thing about this finish reason. This is the only place in the entire API where I had to tell JSON, hey, here's the name of the field inside the JSON data. Now, why did I have to do that? Well, remember back here when I created my JSON object, I set the field naming policy to lowercase with underscores. And if you look at the API and all the details here, everything they talk about uses lowercase with underscores with one exception. And it's that finish reason. Finish reason in this JSON data should have been finish underscore reason, and then everything would have mapped to it properly. But because it's already in camel case, it didn't map correctly unless I went in and said, oh, by the way, the serialized name actually is finish reason here. So it's a tiny inconsistency in the API that I had to compensate for. Now, I also get this seed back, but I don't care about the seed. Okay, there we go. So this time in my generate images, I want to make a post request, not a get request, and get back this object. Now, the post request says, again, use a builder, go to the proper URI. I'll set the authorization header, of course. This time I'm setting both the content type header and the accept header because I'm sending JSON data and I'm getting back JSON data. This is a post request that's going to take the string in there and wrap it into the body and transmit it using this response, again, getting back a string, take the body of that string back and convert it to the proper type, which in this case is my artifacts object. So what am I going to do with the artifacts? Well, what I want are the base 64 strings out of it, and then to parse them into PNG files. Not really parse, decode is really the term. So what I'm going to do is go from the response, the artifacts plural, down to the individual artifacts, turn that into a stream. I'm going to filter them by checking that that finish reason is not an error. I made an enum out of those just so I don't have to worry about it. Here's the enum that's either success or error or content filtered, which would mean that it got blurry for some reason. Okay, I don't care. What I really care is I didn't get an error back. So that's my filter here. I'll map them by extracting the base 64 property out of that image, and then I will write them all to files. Now I use this as a filter because my write image to file method is going to return a Boolean, assuming it worked. It's going to return true if it came back fine, otherwise it'll throw an exception. And after they're all written to a file, I'll see how many made it through, and then I could just say, hey, I wrote that many images to the file. For your information, the write image to file method here takes that string of image data. I make a file with the following naming convention. I start with the word image. I put in this date timestamp, year, month, day, hour, minute, second. I put a counter, 1, 2, 3, 4, 5, just to distinguish between images that all have the same timestamp. I put them in a folder called source main resources/images, and this is where the magic happens. I use the base64 class from java.util, get a decoder, call decode on the image data, and then just call files.write to write that into a file, and I'm done. I mean, files.write even closes the generated file, so I don't need to do that in a try with resources block or anything. So this is taking advantage of the new I/O features, you know, the NIO package from Java I/O, and that works just fine. So let's run it and see what it does. Over here in my tests, I'm going to do this. I'm going to say, let's generate images, and here's my text block, my multi-line string. It says a realistic photo of a happy robot leaping into the air in joy after accomplishing a particularly difficult task. Not a great prompt as these things go, because it's not terribly descriptive of the environment, of what the, you know, more descriptive things about the image. It's more just an emotion and a robot, you know. But what the heck, I'm going to generate 4 of them, and let's, you know, use up those credits. So let's take a look. Let me run this now. Now it took, I don't know, 20, 25 seconds, not a lot. I do find this is generally a lot faster than Midjourney, but depends. I mean, it varies depending on the load and how many steps and all of that. But notice I did in fact get 4 images written to the source main resources images folder. So if I go look at that folder, then I see that I have 4 new images there. Let's take a look at them. Here's the first one. Not much of a leap, but okay. How about this one? There we go. There's a robot leaping into the air. Look how much fine-tune or fine detail is involved in these. Stable Diffusion XL is really good. There's another one, and then here is the final one. Oh, I like that one too. That's pretty good. So at any rate, that's all there was to it. It's not that difficult. It's not terribly complicated. I've saved them all to directories. I have a little image rotation, you know, little carousel that I can use to display them all if necessary. They all look really nice. And I suppose I should find out, what did this cost me? So let me run the get balance one again and find out that I'm now down to 964 credits. So that may have cost me, producing this video may have cost me, I don't know, a nickel? Something like that, maybe 7-8 cents, I don't know, something like that. So there you go. There's your overall cost and everything like that. I hope you enjoyed this video. If you found that interesting, I have other videos in this series as well, talking about how to use the DALL-E image generator from OpenAI. I've got some others that talk about how to use ChatGPT as well in order to incorporate that into this system. And I'm expecting my next one will be using the Spring framework to automate a lot of that infrastructure, a lot of the networking, and it of course also comes with its own JSON parser. They use Jackson over there. So look for that coming very soon. In the meantime, thank you very much for watching, and I hope you enjoyed it. Take care.